My hoodie may be red, but the sky is extremely blue right now. Twitter over the last few days has felt like an over-engineered invite code sharing app again, but this time it's for Bluesky. We have yet another next in social media aiming to kill Twitter, so let's talk about it. And more importantly, let's talk about its underlying technology, the AT protocol, because it has some cool elements to it. So, for context, Bluesky originally started with Twitter support a few years ago. So Jack Dorsey, the founder of Twitter, helped fund the creation of Bluesky and AT Protocol. And the TLDR version of the history is that Jack wanted Twitter to become a social media protocol, not a platform. Clearly, it didn't work out like that. So he funded Bluesky around 2019, 2020, and shortly after that, he resigned from Twitter, and Parag took over as CEO. Then later on, messages between Jack and Elon Musk came out when Elon was taking over Twitter, showing that Jack believed in the future for decentralized social media, right? And Jack's new company today, TBD, is a core contributor to Nostr, a Bitcoin-based decentralized identity network, which has its own flavor of decentralized social media on it. And Bluesky is kind of a thing he funded in the past that has since been funded by other people as well, that has now started to come to fruition. So today we have multiple different Twitter killer type next-gen social media clones. We have Mastodon, Lens, Farcaster, Bluesky, Nostr, Orbeez, and probably more with varying levels of success. So let's look into what makes Bluesky special. So Bluesky builds on top of the AT protocol. AT protocol is the authenticated transfer protocol, and it's the core primitives, the core primitive protocol for building a social application. Bluesky is one implementation of a social application on top of AT protocol. There are three key parts of AT protocol that are interesting and we should talk about. It's the identity system, the concept of data repositories, and the federated network as a whole. So identity on Bluesky is actually very interesting in the sense that your handle on the application is actually a domain name. So instead of you just being able to create an account and choosing whatever username you want, it's a domain name. So it can be a domain name like alice.com or any other domain name that you own. And if you don't own a domain name, you can sign up for a subdomain at bsky.social. So your handle either looks like a web domain name like alice.com, or it looks like a subdomain like hardik.bsky.social. Then this handle then points to a DID. A DID is a decentralized identifier. It's an emerging W3C standard about how identity and identifiers can be managed in a decentralized way. Bluesky specifically uses a DID method called did placeholder that they created. So the DID is supposed to be the canonical representation of your account. So your handle can change, right? Over time, you can buy new domains, you can change your handle to a different domain or whatever, but your DID is supposed to stay the same. Your DID is supposed to be what uniquely identifies you as the same person over time. You can do this resolution from the DNS name to the DID through a method that's present in the AT protocol. And if I open that, you see I opened it with my handle, hardik.bsky.social, and it gives me my DID placeholder. Then once you have the DID placeholder, this can further be resolved into a DID document. A DID document is what actually contains information about your account. So once we have this DID, we can resolve it further using the did placeholder resolver, and we'll end up with a did document. This is my did document. And if we look at this did document, there's a couple of interesting things. So first of all, my did document points back to my handle. So it says this DID is also known as hardik.bsky.social. The other thing it has a verification method, which is a public key. So when you create a Bluesky account, when you're using Bluesky, everybody has a public-private key pair, and my public key is part of this DID document, and it's used to verify cryptographic signatures I do whenever I'm posting something new to Bluesky. And the last thing here is a service, and the service it points to a personal data server, which is currently bsky.social. So we're going to get into what this means, but the core concept of identity comes down to your DNS name can be resolved into your DID, which can further be resolved into your DID document, which then again contains a reference back to your original DNS name. One very important thing to note right now, though, is this DID method that they chose, did placeholder, is currently centralized. So the placeholder, the resolution of a did placeholder into its DID document happens through a centralized server, right now hosted at plc.directory, but the name did placeholder was chosen as a cheeky reference to the fact that the team believes that this is going to change. So they will not be using did placeholder in perpetuity. They hope to change out this DID method for something that's actually decentralized and doesn't depend on a central server like plc.directory right now. So that's about identity. And moving on over to data repositories, and this is the most technically complex part of this video. Spend some time on this, watch it a couple times if you need to. There's some very interesting things that are happening over here and some complicated topics we're going to get into. So, what is a data repository? A data repository is, you can think of it like a Git repo. So if you're a developer and you've used GitHub, you can think of it like a Git repo, where it's a place where you can push commits or essentially like push updates to your data repository over time. And those commits then join together to create a verifiable linked list of commits that together represent the current state of what data is stored in your data repository. So visually, if you have to understand this, each repository has basically what's called a root, some collections, and then some records. So for my data repository, I have the root hardik.bsky.social, and within my data repository root, I have a bunch of different collections. A collection is essentially a group of types of things, types of data that can be stored in your repository. So this includes things like posts on Bluesky, it includes things like likes on Bluesky, it includes things like follows, so when you follow somebody on Bluesky, and so on. So there's a collection for each type of thing or each type of data that can be stored in your data repository. And within the collections, there are a bunch of records. The records are the exact thing that is part of it. So like under the post collections, there are multiple post records which actually describe that specific post. We can look at it by going through the list records function on the AT protocol. And you can see for my repo, for hardik.bsky.social, if I list all the records present in the bluesky.feed.post collection, it's going to show me all the records under this collection. So for example, this is a post I made earlier, which is a post with the text, amazing, thanks. And this is actually a reply to a different post. So this is the conceptual idea of how data is stored in a data repository. But when we start looking at like technically how it actually works, it gets more interesting. So I hope you've brushed up on trees recently, because we're going to talk about Merkle trees and binary search trees. So just a quick refresher, a Merkle tree is a data structure in which each leaf node of the tree contains a hash of the value that you'd want to store. So for example, if I want to create a tree which stores the numbers 1 through 4, there would be 4 leaf nodes where each of them is storing the hash of those values. Then, for example, over here, when you have hash 1 and hash 2, the parent node of these two contains the hash of the hashes of these two values. So if this is h1 and h2, this contains the hash of h1 plus h2. And similarly over here, this is h3, h4, so this contains the hash of h3 plus h4. And then even further, these two guys' parent contains the hash of both of these things combined, and so on. So Merkle tree essentially starts off that the leaf nodes have the hash of the actual values you want to store in the tree, and then the tree keeps going up one level until you end up with a single root, a Merkle root, that is essentially a hash of all the different values. Now, Merkle trees are very useful for verifying that a certain thing is part of the tree, and it's very easy to prove that. I won't go into details around how Merkle proofs actually work. You can find a lot of information, a lot of videos around it, but the core property why you would want to use a Merkle tree is that it's very easy to construct a proof to prove that a certain value is part of that tree without needing to search through the entire tree one by one. Now, let's revise a binary tree. So binary tree is a different type of tree that's optimized for searching. It's optimized for binary search. So if you have a binary tree that contains the values 1 through 6, for example, the way it's structured is there's a top node. To the left of the node are values that are smaller than it, and to the right of the node are values that are bigger than it. And this goes on recursively. So this is an example of a valid binary tree that contains the values 1 through 6. You can see to the left of 4 we have 2, and then to the left of 2 we have 1 because it's smaller than 2, but to the right we have 3 because it's larger than 2. But this whole thing is still smaller than 4. And similarly to the right over here we have 5, and then to the right of 5 we have 6, and to the left it's an empty value, you have nothing over there. So binary trees are very useful for searching, because if you're looking for a specific value, let's say 5, you start at the root node, you start at 4, and you're like, okay, so since this is 4 and 5 is greater than 4, I can basically skip out everything to the left of this and just straight up go to the right node. And then you go to the right and you're like 5, and I'm like, okay, I found it, right? So you can perform searches in logarithmic time in a binary tree. AT protocol basically made the love child of these two things. They made a love child out of Merkle trees and binary search trees and implemented what's called a Merkle search tree. Now, Merkle search trees are interesting because with them, you get both the properties of both those trees. So you can easily prove that a certain piece of data is part of that tree, and also you can search for certain pieces of data in logarithmic time using the properties of a binary search tree. So essentially what happens over here is, let's say we want to create a Merkle search tree for values 1 through 6. So at the leaf nodes, we have a bunch of values. So we have hash 1, hash 2, hash 3. This is also a leaf node. It has no children. Then we have hash 4, hash 5, and hash 6. The parents of these two values is hash of 1 plus hash of 2. I'm going to represent it as hash 1, 2, following this convention over here. But along with the hash, it contains one other thing. It contains a range of values that are present under that node. So along with the hash of these two nodes, it also contains a range saying below me, my children have values ranging from 1 to 2. So it gives a minimum and a maximum. Leaf nodes obviously don't have this because leaf nodes don't have any children, but every node which has children has a range attached to it. So you can look at that in here as well, where the hash 1, 2, 3 contains a range of 1 to 3. Similarly, here hash 45 is 4 to 5, and hash 456 is 4 to 6, and hash 1, 2, 3, 4, 5, 6 is 1 to 6. So this gives us the properties of the Merkle tree because it's a hash tree. It's hashed up all the way until the top. And it gives us the properties of a binary search tree because let's say you're looking for the value 5, you come at the root node. The root node is like, my children have values 1 through 6. So you're like, okay. And they're ordered in a way that, smaller values are to the left and larger values are to the right. So you're like, okay, so I'm looking for the value 5, which is in the second half of this range. So I'm going to go to the right. You go to the right and it's like, okay, I have values 4 to 6. And you're looking for the value 5. So then you check its children and you come across over here, which is 4 to 5. So you're like, okay, this node has two children, 4 and 5. So 5 is going to be to the right because it's the larger one. So you can still perform search in logarithmic time while maintaining the Merkle tree properties. Now, we can look at how and why this would be useful if we try to search for a specific record in my data repository. So we can do this using the getRecord function. And you can see I specified the repo, I specified the collection, and I specified the R key, which is the identifier for a specific record. And when I use this, when I call this function, it gives me that specific record. It doesn't have to do a linear search. It doesn't have to happen in ON time. It can just use the Merkle search tree and the binary search tree properties to find it in logarithmic time and return that to me. So I think that was pretty interesting. The combination of a Merkle tree and a binary search tree was pretty interesting to me. But that's what a data repository is. And why we're learning about this is going to come in useful for when we talk about federation. But basically the way it works is when you first create a Bluesky account, right? When you first join the network, initially your data repository is pretty much empty. There's probably only one operation in there, which is your create account operation, things like that. So at time 0, you have a certain commit. So every update to a data repository is called a commit. Every action you take, like posting something or liking something, following something, all of that are actions you take that are posted as commits. So you have a certain commit at time 0, which is your create account. And this commit is represented as a Merkle search tree inside like the storage. So this Merkle search tree has a certain root node. It has a root node hash, as all Merkle trees do. Then at time t1, you push a new commit. So you make a first post, or you follow somebody for the first time, or whatever. You create a new commit, which creates a new Merkle search tree, which has a different root node. And then what you do is you sign over the previous root node. You include a signature of the previous root node in your new root node. So by doing this, your commit at t1 now references the commit at t0 because you included a signature of the last commit in your new commit. And then you keep on doing this. So commit at t2 includes a signature over commit at t1, so those are linked forever, and so on and so forth. So every time you take an action, you push a commit that updates the tree, that creates a new root node, and you include a signature over the last root node as part of that commit to have a verifiable linked list chained together. So that's data repositories. Now let's talk about federation. So federation is the idea that multiple organizations, multiple companies essentially come together to agree on a set of standards, to agree on a standard of operation collectively. Bluesky is built on top of the AT protocol, right? And the goal is for the AT protocol to be federated and for Bluesky itself to also be federated. So what this would mean is that at the end of the day, there would be multiple servers, or they're hoping that there would be multiple servers run by different organizations. There's already the bsky.social server that's being run by the Bluesky team, and the hope is there will be more servers run by other organizations in the future that would all agree upon the standards of the AT protocol, so they can all work together interoperably. So currently, since there's only one server, the bsky.social server, all the data repositories of all the users live on the bsky.social server. But in the future, once there are more servers, there's server 2, server 3, however many servers, they can all work together and users can choose to have their data repositories on whatever server they want, including being able to run your own server where the only data repository is yours. This is very similar to matrix.org. So if you've heard of Matrix before, or if you haven't heard of Matrix before, Matrix is a communications protocol. So Matrix is essentially to Slack or Discord what Bluesky is to Twitter. So Matrix is a federated protocol for communication, and it has been out there for many, many years now. And it's kind of a similar concept where anybody can run their own Matrix server. Users can register on a Matrix server of their choice. They can have their user data stored on a Matrix server of their choice. You can run your own. You can join an existing one. You can talk to people from other servers. You can join a group chat with people from other servers and so on. So for example, if you look at this, this is a Matrix client. This is an application I use that is built on top of the Matrix protocol. And you can see I'm part of this group chat over here where different people are from different servers. So if you click on this guy, we'll see this guy is registered at the matrix.org server, which is the analogy to, I guess, the bsky.social server. And you can see this guy, however, has a different server, maunium.net, and so on and so forth. So different people are registered on different servers, but they can all still come together to talk together, and it just works. It's interoperable. That's what federation is. So once in a federated network, once these different servers are running, what is necessary is that these different servers can sync data with each other. So if you're following somebody who's on a different server, your server will be syncing data from their server. They'll be exchanging data between the two data repositories. And this is why having a data structure that is good for search is very important. So you can search for things from their data repository, you can sync them together, and so on and so forth. A key point to note here is only one server exists right now, as I said, which is bsky.social. So the whole network is kind of pretty centralized right now. There's only one server, and also the did resolution method, the did placeholder resolver, is also centralized right now. So depending on when you're watching this video, this may have changed already, and you may be able to run your own server now, but at the time of recording, that is not the case. Generally, what's good about this possibility is the idea of choice. So going on with the matrix analogy, the advantage of matrix is there are so many switches and knobs you can tweak. There are so many things you can do by yourself that it gives you full control over what sort of experience you want. So bsky.social, for example, has certain settings around how content moderation should work, like what is shown to you, what is not shown to you, how that is decided. They have certain content moderation settings. This is also the case with Matrix. The default Matrix server has certain content moderation settings. But when you run your own server, you can change that up. You can tweak things like that to customize what you'd like to be shown, what you'd like to not be shown. It gives you the freedom to configure all of those different things. You can also configure what sort of data you'd like to be made available to other people, or who else can join your server, and so on and so forth. So it gives you a lot of choice, and it gives you the power to choose who you're trusting or what server you're trusting to keep your data. But as I mentioned again for the third time now, the biggest con is the protocol isn't fully released yet. And it's not really a con, it's just the state of things. It's not fully released yet. It's under active development, and it's not marketed as a production-ready piece of software. And because of that, certain things are still centralized, and certain things aren't fully where they need to be. One last thing I'd like to talk about over here is we have to think about sustainability. Matrix has funded itself over the years by relying on grants and corporate sponsorships and things like that. They have succeeded, they've been alive for a long time and have had enough funding to have core developers on the team who are continuously updating the protocol and fixing bugs and all of that. But relying on grants and relying on corporate sponsorships isn't really a model that can easily be copied. It's hard to replicate, to have that sort of level of attention where people are donating you essentially enough money to sustain you over time. So how Bluesky is going to be sustainable and fund itself is something that's not super clear right now. Another approach we've seen from Farcaster is they've mentioned that they're eventually going to start having a subscription model where you have to pay $10 a year to be able to use Farcaster. So that's an option that maybe the team is exploring. I'm not sure, but keep in mind you have to think about sustainability, because if the organization cannot sustain itself, it's going to die, right? So is this a Twitter killer? Well, Twitter today has over 200 million daily active users, right? Bluesky in total has less than 100K users. So it's nowhere close right now. It's also, again, it's not production-ready software. You still need an invite code to even join the application and create an account. So it's nowhere close. There are other next-gen social medias that are trying to do similar things. We have to wait and watch and see where it goes and how adoption goes, because adoption isn't always proportional to how good the technology is, right? There are other things to getting something adopted. The tech is definitely interesting. It has some interesting parts. It has some downsides as it exists right now, but if you have access to it, might as well try it out, build some things on top of it. And I for sure will continue looking into this, and I'm going to try to build some things on top of it. That's it. That's the overview of Bluesky and AD Protocol. Hope this helped. Peace.